Hi everyone, in this lab, let us understand one more use case for replatform migration approach. This is basically moving to the managed database. In the previous demos, if you remember, we had migrated the front-end UI to S3 for the static web hosting, and also the web application which was running on EC2 machine, we migrated that to App Runner. Okay. Now the third tier, which is a database tier, we are now migrating from a self-managed MySQL database running on EC2 to a managed database in AWS. Let's get started. So this was our previous architecture where we had the front end stored in S3 as a static web hosting. Then the middle layer, which is the app layer, is hosted on App Runner. And the third one, which is a database still running on the EC2. So in this lab, what we will be doing is we will deploy one Aurora MySQL regional cluster in the region where we deployed this. And we'll also use one more service called database migration service, which is called DMS. We use the DMS service and migrate the data from the existing database, which is on EC2 to the Aurora MySQL database. So once the data migration is completed, then we have to switch the traffic from App Runner to the Aurora MySQL. So that means we don't require the EC2 machine any longer. Okay. So this is how we will be completing the lab. Okay. Now just to put together everything, how does it look like the final architecture? So we have the front end UI on S3, app layer on App Runner, and the database on Aurora MySQL. So this is completely cloud native way of deploying the microservices in the cloud. Okay. Let's get started and go to the code. So in this lab, let us understand how to implement the move to manage database use case for the migration story that we are building so far, right? So we are using the Terraform for the entire lab series. So we have to do the init, plan and apply. So before that, let us understand the code. So if you look at db-aurora.tf, this is a code where we are creating a Aurora MySQL database. So I'm using the latest version for this module, and I'm providing certain engine configuration, which is Aurora MySQL. You have one more option, Postgres, but in this case we are using MySQL. Then I'm using 5.7 version for the MySQL engine. Then I'm using the engine mode as provision. Then the master managed user password is false because I do not want to use any secret manager to manage for now, just for the demo purpose. I'll be using hard coding the username and password. Okay. Then the port number is 3306. This is where the MySQL server will be listening. Now the database subnet group is already created earlier when we created the VPC. So I uploaded that the subnet group name into SM parameter in the lab1 module, and the same thing I'm reading through SM module. Okay. And this instant class is db.r6i.2xlarge. So this is the instance I'm using, and I'm using only one instance here. So the first one is publicly accessible is false because I do not want to access through internet, because the app runner, which is a middle layer, will be accessing this inside the AWS network. So publicly accessible should be false. And I don't have many other instances, only one instance, which is the writer and the master, right? And the VPC ID is the same VPC that is used for hosting the EC2 machines earlier. And this is a security group of the database EC2 machine. Okay, the same EC2 machine security group I'm using, and few other variables I'm just using. Okay, so this is the Aurora SQL database creation, and let's look at the DMS also. This is a database migration service configuration. So in this case, again, I'm using this DMS service module with 2.2, which is the latest version, and I have to create a subnet group with this name, and the subnets which I'm using is the private subnets from the VPC. This is the subnet on which we hosted the EC2 machine in the previous labs. Okay, the same subnets I'm using, because the replication instance has to talk to the EC2 server where the database is hosted. Okay, so it's important that the same subnets are used. This is a instance ID and the instance class, and it is not publicly accessible because we are using only inside the VPC. and this is a security group. This is the EC2 uh, machine security group where the database is hosted in the self-managed lab. Okay, so as we know in the DMS service, first we have to create a replication instance on which we'll be running some task. Okay, so to run the task, we require the endpoints, source endpoints and the destination endpoints. The source endpoint is basically the MySQL server. So this is a private DNS IP, DNS name of the EC2 machine where we hosted the MySQL community version on the EC2 machine. And this is the source, this is the engine name, and this username and password to access the database. Similarly, the target will be the Aurora database that we have created and the same port, and we are using the same username and password. And so this is the endpoint of the database that we created in the previous code. Okay, and once we configure the source and the destination endpoints, we have to configure a task. Okay, the task is configured this way. This is the task ID and this is the migration type. In the migration type, you have full load, which means just one-time copy of the data from the source to destination, and there is a full load and CDC, continuous data copy, or there is a CDC. So there are three different options, but for this lab, we are using full load, which is one-time copy of the data from the source to destination. And there are few task configuration that we have provided as a part of this task settings.json file. So this is referred here. Similarly, for the tables also, there is a mapping. So tables.json. So what kind of tables mapping from source to destination we have to use. So all of that is configured here. Then the source endpoint key and the destination endpoint key. This is exactly what we configured earlier. MySQL source and MySQL target. So this is the source endpoint key and this is the target endpoint key. Okay, so this is how we are configuring the replication instance, the endpoints with the source and destination, and also the task, the actual task which will copy the data. So if you look at SSM code, if you see we are using the data resource to get the data from the previous modules. Basically, in the previous modules, we uploaded this data into the parameter store. Now we are basically copying that, right? Now let's go to the Terraform init. It is done. Terraform apply, Terraform plan, let me run. Um, so Terraform plan is done. Then I'll do Terraform auto apply. So Terraform apply also completed, and this is the cluster endpoint. Now let's go to the AWS console to see how these resources are created and looks like. Okay. So this is the Amazon RDS console. So within the database section, so we have created one database with the name AppMart, and this is a regional cluster. Aurora also supports global clusters also, where you have clusters deployed across the regions and syncing between them. But for this demo, we are using the regional cluster, and there is one writer instance. You can have multiple reader replicas also. So this is the size of the instance that we have configured, and these are the endpoints. This is the writer endpoint and this is the reader endpoint. So later we will be using this endpoint to configure the app runner service. Okay, so this is how the configuration looks like for the database. So if I click on the app mod, the regional cluster, and look at the configuration, so this is where you see the engine version of 5.7 and provision cluster, and the username and password we configured, and few things like multi-age is no, encryption is enabled. This is the cluster ID. So this is the typical configuration that we have configured in the Terraform file. So similarly, if I look at the writer instance, this is the configuration. This is one instance number one, database engine version. This is the CPU and the memory, and so default options are already created. We didn't specify the other options like option groups. Everything is taken care automatically. So this is a configuration for the Aurora MySQL database. Now let us go to the DMS database migration service and see how it looks like. This is the AWS DMS service uh, console. So in the migration data, this is replication instances. So we have created one replication instance called AppMart, and it is deployed in this same VPC. its class is this, and the engine version is 3.5.1, and a few parameters. And the endpoints are configured here. So there are two endpoints. One is the source, one is the target. The source is again MySQL. The target is Amazon Aurora MySQL, and the source server is the EC2 machine. The destination server is the Aurora cluster that we have configured earlier. The port is same. So I went into the MySQL source and look at the connection. The connection is successful. So before we start any migration task, we should ensure that the connection is working fine to the source and the destination also. So this is for the source. Now let's look for the destination. So for the destination also it is successful. That means the task, the replication task is able to connect to the source and the destination. And this task is running on the replication instance that we have seen earlier. Okay, now let's go to the actual replication task configuration. So if you go to the database migration task, so this is where we configured a migration task, and it is saying load complete. It has 100% copied the data. It's a full load migration source to destination. Okay, this is already completed. So within the migration task configuration, you can see the task settings JSON file that we provided earlier. The logs are also configured to CloudWatch. So this is this is same as what we configured in the Terraform. So in the table statistics, you will see the schema name, the tables from the source, and how much time it has taken to complete the transfer. Some statistics around the actual transfer of the data. Under the mapping rules, table, you will see the mapping different rules. So the mapping rules JSON file. So this talks about what schema, what is the name, and what tables we're copying from source to destination. So all of that we have seen in the JSON file in the Terraform code. Okay, so now that the data is completed successfully from source to destination, the copy is done. So now let us go to the app runner and configure the database endpoint. So I'm inside the app runner console, and within the app runner for my particular service, which is appmad-web-app. So I configured the variable which is mono to micro database endpoint. So this was pointing to the EC2 machine private DNS earlier. I now change it to the database endpoint. Okay, so that means for any database request, it is now going to the managed database, not the self-managed database on the EC2 machine. So I've already applied this configuration and it has been successful. So this is the UI, okay, the front end UI, and which is hosted on S3. And from S3 it is talking to the app runner, and app runner is talking to the database. Now if you see, all the data is there, so that means we are able to talk to the the Aurora database, right? So this concludes the end-to-end story of migrating from on-prem to the cloud using the cloud native technologies, right? So so just to conclude, we migrated the front end to S3, the middle layer app layer to the app runner, and the last one, the database, to the managed Aurora. Okay, so this concludes the lab 3.